A new spacecraft is set to deliver Chinese astronauts to the lunar surface within this decade, according to official statements from the nation's space agency. They have substantiated these claims through a recent demonstration of the vehicle's launch and landing capabilities. The craft is designated the Laney, a name translating to embracing the moon, and its form unmistakably resembles a lunar lander. The design draws clear inspiration from NASA's Apollo-era lunar module. Photographs reveal the Chinese lander positioned alongside personnel for scale reference, displaying proportions that feel recognizable, though significant modifications have been incorporated into the propulsion architecture. The Apollo lunar module functioned as two distinct systems integrated into one vehicle, a descent and landing stage positioned below, with an ascent stage mounted above. When the time arrived for departure, astronauts ignited their engines and abandoned the landing apparatus on the surface. The new Chinese test vehicle demonstrates a markedly different approach, utilizing a single stage that serves both touchdown and departure functions. The most comprehensive footage available from a landing test was captured at night, allowing clear visibility of the engine systems at work. 4 primary thrusters encircle the crew compartment, while an outer ring of reaction control jets positioned around the landing legs manages vehicle stability. This configuration stands in sharp contrast to Apollo's architecture, which featured one centralized landing engine supplemented by reaction control. Thrusters mounted near the upper section. Chinese space officials have indicated that the lander incorporates multiple engines, arranged in a redundant configuration, each capable of backing up the others. Should a single engine experience failure, the remaining propulsion systems retain the capacity to safely return the astronauts to lunar orbit. The extensive framework of metal towers and cables enveloping the vehicle serves a dual purpose. First, it provides protective safeguards against accidental impact. Second, it facilitates the simulation of lunar gravitational and atmospheric conditions. Given that the moon's gravity measures 1/6 of Earth's force, the cable system logically supports approximately 85% of the lander's weight throughout testing. The apparatus simultaneously mitigates wind interference, a factor non-existent in the lunar environment. This represents an elegantly engineered testing solution. The same infrastructure previously supported evaluation of the TN-1 Mars lander years earlier. Available information indicates the entire operation concluded favorably, though Chinese authorities released neither specific performance objectives nor commentary regarding alignment with lunar landing schedules. What remains confirmed is China's objective, to position their personnel on the moon prior to 2030. The Laney constitutes a central element of this initiative, yet represents merely one of numerous designs undergoing accelerated development throughout the decade. The Mango spacecraft complements this architecture, functioning to transport crews from Earth's surface through lunar orbit and subsequently homeward. China conducted preliminary testing of this vehicle's initial prototype during June, executing a suborbital flight followed by evaluation of the capsule's abort system. Diverging from the original Apollo approach, China's lunar mission architecture involves deployment via 2 independent rockets, one designated for the Laney and another for the Mango. These spacecraft will subsequently rendezvous within lunar orbit. The Long March 10A rocket has been engineered for this mission, incorporating 3 clustered cores, each powered by 7 liquid-fueled engines. This configuration mirrors SpaceX's Falcon Heavy in appearance and operational function. China anticipates conducting their inaugural single-core Long March 10A launch within the approaching 12 months. The preliminary design prototype of China's lunar extravehicular activity suit, named the Wangu, was unveiled approximately 1 year prior. The remaining critical component involves the lunar rover, designated Tenno, essentially functioning as an electrically powered terrain vehicle. This element likely represents the least technically demanding aspect of the complete mission architecture. Evidence demonstrates that Chinese efforts are advancing measurably, a fact beyond dispute. However, velocity of progress does not supersede fundamental requirements. The nation must simultaneously engineer systems capable of reliable performance. To date, their track record suggests competence in this dimension. The question remains whether this combination proves sufficient to transport personnel to the lunar surface and facilitate safe return within this decade. Time will ultimately render the answer. Turning attention to similarly ambitious schedules, Rocket Lab's chief executive Peter Beck communicated to financial stakeholders his continued commitment to achieving the inaugural launch of the company's Neutron rocket during 2025. Neutron represents Rocket Lab's maiden fully reusable booster platform, constituting a substantial advancement beyond their existing Electron vehicle. The Electron has demonstrated exceptional dependability, achieving 65 successful missions among 69 total launch attempts, yet its payload capacity extends merely to approximately 300 kilograms delivered to low Earth orbit. Nevertheless, this platform has enabled Rocket Lab to pioneer innovative technological approaches. The Electron structure incorporates carbon fiber construction and operates via 9 Rutherford engines produced through additive manufacturing techniques. These engines represent the inaugural rocket propulsion systems to employ electric fuel pumps powered by lithium battery. Technology Neutron signifies the company's first transformative progression forward. Beyond mere size and power increases, it embodies a completely reusable booster configuration capable of executing propulsive landings on ground-based installations or floating platforms. The design incorporates an exceptionally innovative reusable cargo fairing mechanism, functioning analogously to a clamshell apparatus that opens and closes, subsequently returning to Earth while remaining affixed to the booster stage. During the previous week, Rocket Lab successfully completed their initial hot-fire test of the newly developed Archimedes engine. Beck emphasized that this represented not a prototype or experimental candidate, but a flight-qualified engine operated at maximum power output throughout an extended duration burn cycle. He further stated that subsequent work would concentrate on optimizing the engine's performance, manufacturing multiple units, and establishing continuous production operations. Beck reiterated that Neutron remains aligned with an end-of-year launch trajectory, contingent upon sustained favorable circumstances across all program elements. Simultaneously, he underscored that mission accomplishment assumes priority exceeding schedule adherence. During the company's recent investor presentation, he articulated that Rocket Lab would not compromise safety or execute unjustified risks to achieve a Neutron launch prior to genuine readiness within the vehicle and program's life cycle. He emphasized, the calendar variations spanning several months carry negligible significance. Beck stressed unequivocally that no shortcuts would be implemented to expedite launch operations for arbitrary deadlines, a potentially veiled reference to competitors who have pursued accelerated schedules. His comment addressed a competitor's initial Starship launch on April 20th, which resulted in destruction of the launch facility, followed by numerous engine malfunctions and eventual loss of vehicle control and structural failure mid-flight. When the competitor's leadership characterized this outcome as a successful test, Beck responded with pointed candor, stating that his organization would not disseminate misleading claims regarding pad clearance constituting success. For Rocket Lab, a successful Neutron launch specifically means achieving orbital velocity. The booster return will receive marginally increased tolerance, with optimal objectives involving a controlled splashdown of the first stage in the Atlantic Ocean. Beck acknowledged that initial landing operations will constitute a learning process. Neutron operates from a distinctly unique launch facility. Rocket Lab recently finalized their new launch complex located on Wallops Island in Virginia, positioned considerably north of the established American spaceport at Cape Canaveral in Florida. Rocket Lab deliberately selected this location to reduce launch capability bottlenecks within the United States and introduce operational redundancy across multiple launch sites. Should catastrophic incident occur at Cape Canaveral, virtually no American space operations could proceed until recovery. From a national security perspective, Rocket Lab is presently evaluating substantial commercial potential for Neutron integration within the emerging Golden Dome missile defense architecture. Beck identified the $175 billion Golden Dome initiative as potentially representing one of the Department of Defense's largest procurement activities, with Rocket Lab positioned advantageously to capitalize on resulting opportunities. Consequently, Rocket Lab has announced acquisition of a company called Geost through a $275 million transaction, consisting of $125 million in immediate payment with the balance satisfied through Rocket Lab equity. Geost specializes in developing technologies supporting missile detection, tracking capabilities, surveillance operations, Earth observation, and space domain awareness functions. This acquisition directly aligns with Golden Dome requirements, positioning Rocket Lab to furnish both the launch vehicle and orbital platform technology, essentially a comprehensive provider for space-based defense infrastructure. Beck additionally envisions military application for the Electron vehicle, extending toward offensive weapons deployment. Rather than retiring the Electron, Beck intends to repurpose the platform as a weapons delivery system. Designated the Hypersonic Accelerator Suborbital Test Electron, abbreviated HAST, which underwent initial testing in June. The company declined to disclose payload specifications or velocity and altitude parameters, though they confirmed the test achieved its intended objectives. In this reconfigured state, Electron accommodates a 700-kilogram payload on a suborbital trajectory, meaning terminal impact would occur at a distant geographic location. The specific nature of such payloads remains undisclosed, whether explosive ordnance, supply deliveries, or advanced weapons systems. Nevertheless, this represents a compelling strategic pivot in Rocket Lab's operational model, suggesting significant developments ahead. Continued monitoring remains warranted, with ongoing attention directed toward emerging developments. For enthusiasts tracking the transforming landscape of spaceflight operations, channel membership represents a consideration worth exploring. Your participation directly fuels our investigative drive and sustains production of weekly content spanning diverse subject matter. However, a brief hiatus will be observed to provide our creative team necessary respite. Do not be concerned if news programming does not appear for the remainder of this month. We will resume with renewed momentum beginning in September, maintaining our established weekend release schedule.